Today we have a strange looking equation, x squared minus 5x plus 5 all raised to the x squared plus 3x plus 2 equals 1. Now, normally when you see something like solve for x, your first instinct is to isolate x using algebraic manipulation or whatever, but what can you do with this? This variables and variables, it's all quadratic, there's a crazy mess here that you can't really do anything with. But we see that it's an exponent and it equals 1. So that leaves us with 3 possibilities. 1 to some number equals 1. And we can also have minus 1 to some even number is 1. Or we can have number to the 0 equals 1. Note that this number cannot be 0 because 0 to the 0 is not defined. So as long as c is not 0, we can have the exponent 0. And these really are the only 3 ways we're going to get a 1 from an exponential equation. So we look for these 3 patterns. First of all, we look for when the base is 1. So let's solve for that first. Case A, x squared minus 5x plus 5 equals 1. Then we can subtract 1 from both sides. And we factor x minus 4, x minus 1 equals 0. So x equals 1 and 4. Now when you have weird equations like this, it's always important to plug them back in to make sure that they actually work. Now we know if we plug in 1 and 4, this becomes 1. So we just need to plug this into the numerator. This gives us 1 raised to the 1 plus 3 plus 2 is 6. That is indeed 1. And this one gives 1 raised to the 16 plus 12 plus 2. 16 plus 12 is 28 plus 2 is 30. That is also 1. So both of those work. Now we have case B. The base is negative 1 and the exponent is even. So we look at when it's negative 1. X squared minus 5x plus 5 is negative 1. We have x squared minus 5x plus 6 equals 0. And then you can factor that. X minus 3, x minus 2. So x equals 2 and 3. And we simply have to check if this gives us an even exponent. Plug in 2. 2 squared, that is even. 3 times 2, that is even. And 2 is even. So even plus even plus even. This gives us even. This one works. Now 3. 3 squared, that's 9, is odd. 3 times 3 is also 9, that is also odd. 2 is even. Odd plus even. The odd plus odd make an even. And then the even plus the 2 gives us another even. So this also gives us an even. So both of these work as well. And finally we have the case when the exponent is 0. So x squared plus 3x plus 2 equals 0. Factor this as x plus 2, x plus 1. So that gives us minus 1 and minus 2. Now we must plug this into the base to make sure that they don't give us 0, because we know plugging this into the exponent will already give us 0. We need to make sure it's not a 0 to the power of 0. So minus 1 squared, that's 1. Negative 5 times negative 1 makes it a positive 5. And then plus 5 is 11, so we have 11 to the 0. And then plugging in negative 2 squared is 4, negative 5 times negative 2 is 10, and then plus 5 is 19, so we have a 19 to the 0. And both of those do in fact equal 1, so these two answers work as well. So finally, we have 6 solutions, minus 2, minus 1, 1, 2, 3, and 4. Now the key thing to note with this kind of problem is the idea that the answer equals 1, which is what gave us these 3 possible cases that made our solving process a lot simpler. Made it so that we can actually use algebra and things like that to solve the equation. If this was like 3, that really wouldn't be possible, because you could have something like, I don't know, the square root of 3 squared, or 2 to the power of 1 point whatever will also give you 3. And we can't solve for that. This works because it's a 1. And when you have a weird thing like this and they expect you to solve it, it will be solvable in some way. So it is important to think about the possibilities and find what makes the process work.